Hi everyone, am I audible? Hello guys, am I audible? Yes, okay. So, hi everyone, my name is Pradyumn, and today we will be having the PCD for today's Leetcode Contest, and we'll solve the problems from A to D. All the problems we'll solve, okay? But before we start, I will tell you about our newly launched version of TLE's CP31 sheet. So, as if you don't know, this sheet encapsulates 31 handpicked problems from all the ratings from 800 up to 1900, and the problems are chosen in such a way that each problem teaches a unique idea. Our sheet has been upgraded with a new interface, automatically syncing your process with your code process account. So it automatically shows you which problems you have solved. Also, there is a leaderboard where you can compete with your friends and also other peers. Added to this, every week, 7 to 8 solutions, video solutions, will be posted on YouTube. Alright. And the link to this is down below. So let's start. So the first problem today was not this one, not this one also. It was this one. Okay. So you are given an array cost of size n. You are currently at the position n, at the end of the line, in a line of n plus 1 people. Okay. You wish to move forward in the line, but each person in front of you charges a specific amount to swap places. The cost to swap with person I is given by cost of I. You are allowed to swap places with people as follows. If they are in front of you, you must pay them cost of I to swap with them. If they are behind you, they can swap with you for free. Return an array answer of size n, where answer of I is the minimum total cost to reach each position I in the line. Okay. So the problem says that we are in a queue. Okay. So let's say the person 0 is sitting here, 1 is sitting here, 2 is sitting here, I mean standing, whatever, 3 and 4. And we are 4. And the cost to swap with these persons is given by, like, suppose 2, 5, 3, 4 or something. Okay. So if you want to swap with 0, then it will take cost of 2. If you are ahead of him, like if you are behind him, sorry. So the queue is here, like the end of the queue is here. That means this is the front. Okay. And you want to reach here. Let's say you want to reach to 0. Okay. Then what you can do, you can just swap with 0 and it will take cost of 2. And of course there is no other way to reach 0. All right. Now let's say you want to reach 1. Okay. So let's say you want to reach 1. Then what can you do? You can either swap with 1, right? If you swap with 1, then it will take you 5 cost, right? But actually what you can do is you can swap with 0. Let's say you swap with 0. Okay. So it will take you 2 cost. And then what you can do is you are here, right? Now you are here. So now you can swap with 1. And he will swap with you at no extra cost because you are ahead of him, right? So 2 plus 0 is the total cost, which is equal to 2. So instead of incurring 5 cost, you can do it in 2 cost, right? So that's the observation here, that how you can move to 1 with only 2 cost. So in general, if I have, let's say, an array like cost 0, cost 1, cost 2, up to cost n minus 1, and I want to reach the ith position. Let's say there is some ith position, Ci, where I want to reach, and I am currently here at n, right? And I want to reach to Ci. Then what can I do? I can basically either go to CI directly. I can either go to CI directly. So that will cost, like, I can directly go to I, and that will cost me CI, right? And of course, it is not beneficial to move to somewhere between. Like, let's say you move to somewhere CJ, or let us see n minus when you move, and then you move to CI. So that is definitely not beneficial, because it will incur cost of CI plus something, right? So that is not good. So either you can directly go to CI, okay, directly go to CI, or what you can do, like, okay, this will incur you CI cost, or what you can do, you can go to somewhere behind CI, like before CI. Let's say you go to C1, so that will cost you C1 cost, and then you can go to CI, and that will not cost you anything, right? So that means that basically you can, if you want to go to I, then you can move to anywhere before I. Let's say J, you move to J less than I, and that will cost you CJ, right? So of course you would move to whatever is the minimum, like before this I, whatever the minimum cost is, you will move there, and then you will move to CI, and your final answer is that minimum cost in the prefix of CI. So basically your final answer would be just the prefix minimum. That is, let's say we have an array of C0, C1, C2 up to C of n minus 1. Then the answer for 0 is C0. You have to move to C0. Answer for C1 is minimum of C0 comma C1. Okay. Then the answer for C2 is minimum of C0, C1, C2, and so on and so forth. Okay. This is the answer. So is it clear to all? Or if anyone has a doubt, then you can ask right now. I will wait for 10 more seconds. Okay. If it is clear, then I'll show you the code. Okay. So this is the code that I wrote. Uh, it is, yeah, this is the code that basically I am keeping a variable called mi. So which is the running minimum. So I am just iterating over the entire array, and initially this mi is cost of 0. Okay. And I have this ans vector, and I push back mi. So the first answer is just cost of 0, right? Which is mi currently. Now I just iterate over the array from I equal to 1 to n, and I just take the minimum of cost I with mi. So this essentially gives us the prefix minimum, because mi was the minimum till I minus 1, and then I took the minimum of I also. So it is now the prefix minimum, and so I push back into the answer vector, and then I return the answer vector. Okay. If this is clear, then I'll move on to the next one. But before that, I'll wait for 10 more seconds, I guess, if someone has a doubt in this. What was that zero? What? Uh, I don't understand what you are saying. What's your question? Like, could you be more clear about it? In description, What, like that will be free? Like they are saying that if they are behind you, you can swap with them for free. So if you are in a queue, like let's say there's a queue of person 0, person 1, person 2, person 3, and person 4. You are person 4, okay. So let's say first you swap with 2. So now 2 comes here, and 4 comes here. So now you are here. And to do that, you had incurred a cost of C2 because you are ahead of 2. And now if you want to swap with 3, then you can do that for free because they are behind you. Like to go back, you don't need to incur any cost, but to go forward, you need to do that. Okay. So I hope everything is clear till here. So I'll move on to the next problem. Okay. You are given two strings S and T. You can create a new string by selecting a substring from S, possibly empty, and a substring from T, possibly empty, and then concatenating them in order. Return the length of the longest palindrome that can be formed this way. A substring is a contiguous sequence of characters. Palindrome is what palindrome, you all know what is palindrome. So the problem is that you have been given two strings S and T. Okay. And you want to select a substring. Right. So suppose this is S and this is T. And what you have to do is to select a substring. Let's just select this from S, and from T you select this substring, and then what you do is you concatenate them. Like you just take this one, and then after that you write this one. So this new 5 letter string, whatever you get, that is the concatenation, right? So what we want is that this concatenated string should be a palindrome, and also we want that its length should be maximum. We want to maximize its length. Okay. And our task is to print the maximum length. Okay. So return the length of longest palindrome that can be formed this way. So we have to print the maximum length for this palindrome, right? That is the problem here. And there are two versions in this contest. That the first version has different constraints. It has constraints that s dot length and t dot length are from 1 to 30. Okay, so they are pretty low. So many solutions will pass. Like O of n to the power 6 should also pass, I think. Or that will be like borderline, but n to the power 5 will pass. Okay. So and yeah, for the hard problem, like for the version 2, you have um, constraints for 1000. Like their constraints are 1000. So n square solutions will pass, but n cube will not pass. Okay. So first I'll show you what to do in the easier one. So in the easier one, the constraints are pretty low, right? So what you can just do is brute force. Like basically what you do is just check for all possible substrings. Like you have a string S, right? You have a string S, you have a string T. Just iterate over all possible substrings of S and all possible substring of T, and then concatenate them. You concatenate them and then check if they are palindrome or not. So this string plus this string, if their concatenation is a palindrome, then it is a possible answer. So what you will do is keep a max length variable, like max length. Currently it is equal to 0, and while you are iterating, just update this max length with the length of the palindrome that you found. So whatever palindrome you found, just update this max length with this length, like max length comma length, max length comma length of the palindrome. All right. So that is pretty simple. And how do we iterate over these arrays? Like, how do we do that? Basically, the string s, the string s and the string t. So what we do is we keep four pointers, like the start pointer in s, the end pointer in s. Actually, what I have done here is I have taken like exclusive. Basically, this is the start pointer and this is the end pointer. Like in STL, the end is not including the thing, right? Like if we want to denote this subarray, then my end pointer will be here, like to the next element of the last element. So basically you can iterate. So let's say this is I, this is J, and this is for string S, right? And for string T, let's say you have two pointers K and L. So I and J denote the substring from Si up to S of J minus 1, and K and L denote the substring from T, the T of K, up to T of L minus 1. So this whole string, if it is a palindrome, then its length is what? Its length is J minus I plus L minus K, right? So you will take the maximum with this, and you can just iterate over all of these like you can iterate from I equal to 0 to n minus 1, J equal to I to n, then K equal to same thing, 0 to m minus 1, and L from K to m, right? So it's better if I show you in the code only. So if I show you the code for this, basically I have a function called isPalindrome here. Wait, I'll just zoom in. Yeah, so I have a function called isPalindrome, and it just returns if the string is palindrome or not, and that is pretty easy to check in O of n, right? And I have here my iterated for loops, like nested for loops, that int I equal to 0, I less than s dot size I plus plus, right? And int j equal to I, j less than equal to s dot size and j plus plus. So what I am doing here is that I'm iterating from I equal to 0 up to s dot size minus 1, so the last element. And j, I am iterating from I. So let's say I was somewhere. Okay, so let's say I was here. Then I'm iterating j from here up to the next, like s dot size, up to s dot size. So if this is the last element, then I'm iterating j up to here, because j is exclusive element, right? Like I am considering s of I up to s of j minus 1. So if I want to, let's say, denote this subarray, then in that case my I pointer would be here and j pointer would be here. So that's why I am going till s dot size. Okay, and starting from here means, let's say if I and j both are here, then it denotes empty substring, because you can take empty substring as well, right? So this denotes empty substring. So j equal to I, j less than equal to s dot size j plus plus, and same for k and L. We do k equal to 0, k less than t dot size k plus plus, and L equals to k, L less than equal to t dot size L plus plus. So these are four for loops, and we just check if the substring starting at I with length j minus I. So this function s dot substring, this is a nice function which you can use. That this basically returns the substring, like s dot substring. This takes two parameters. Okay, the first parameter is the position, and second is length. Basically, position means the starting position, that where do you want the substring to start. Like let's say you want the substring from this element, so you will pass 2, like this is 0 1 2, right? So you will pass 2 in here, and you want of length 3. like 2 to 4, let's say you want, of length 3. So you will pass 3 here. So it will return this substring from the string. Okay. So I'll just do if is palindrome s dot substring I comma j minus I plus t dot substring k comma l minus k. Okay. So I just concatenate these two and check if it is a palindrome. And if it is, then ans equals max of ans comma length of this palindrome. Alright, so it's j minus I plus l minus k. So I just take the maximum out of all of these n to the power 4 and return ans. Right. And the time complexity for this is basically n to the power 5. N to the power 5, why? Because these are 4 nested for loops. These are 4 for loops, right? So um, it will take n to the power 4. And inside we are checking if it is palindrome. Right? So that will take another O of n. So this is O of n to the power 5. Okay. But that will pass because the limit of n is just 30. Okay. So I hope it is clear. Is it clear, everyone? If anyone has a doubt in this part, then they can ask right now. I'll wait for 10 more seconds. Okay, so it is clear to all, I am assuming. And let's move on to the next one, which is the harder version of this problem. The problem is same as you can see. Like just look at this thing. It doesn't change, right? The only thing that changes is these constraints. Okay, so we have to do it in O of n square or n into m or whatever. So let's think about it. So basically, what we want. The problem is like we had a string s, we had a string t. We want to choose two substring of s and t. Let's say they are u and v, and we want that u plus v is a palindrome. All right. So just imagine, guys. Like, let's just try to analyze what's happening here. Okay. So let's say I have a concatenation of these two strings, like s and t. I have u and v, so I have u plus v as a palindrome. So let's say um this is my u plus v. Like this is my u plus v. Or let's take an example. Okay. If I take an example, let's say A, B, C, B, C, A. So is this a palindrome? It is not a palindrome. Wait a minute. CBA. Okay. So let's say this is a palindrome, right? And let's say that the first four letters are from S and the last two are from T. Okay. So these four letters are from S and these four are from T. All right. So in general, what I can say that okay, since I have a palindrome, so these two will be same, right? Then these two will be same, and then these two will be same, correct? So what I mean to say is that okay, let's assume that length of s is greater than length of t. Like for now, let's just assume. So definitely, let's say length of t is m or length of t is something. Or what will it call it? Let's say it is q. Let's say length of s is p and length of t is q. I mean the substring, not the total length, but this substring of s and t, which we have chosen, let their lengths be p and q, where p is greater than q. So that means that the first q characters of s, the first q characters of s have to be reverse of the the t string, right? Like the first few characters of whatever substring we have taken, not from s, sorry, from u. The first q characters of u should be the reverse of the substring v. Okay, so is this part clear, everyone? That the first t letters of s is reverse, or okay, not of s, the first t letters of u is reverse of v, right? So okay, that is one part. So basically, um, we can divide this string into three parts, right? The one part is which is coming from the substring s and which is the reverse of the t. Then we have another second part which is coming from s but which is extra, like it is not there in t, and then the rest of the string is t. So basically we can, our string we can break into three parts, right? One part is ab, okay, one part is ab, another part is cc, and another part is ba, where abcc is from s and ba is from t, right? So I can basically write let's say this is my palindrome p. Let's say I call it p, okay. So I can write my string p as some string u plus some string w. Let's say this is u, okay, this is w, and plus reverse of u, okay, where u is from, or where u plus w is from s and reverse of u is from t. Either this can happen, or u plus w plus reverse of u. So either this can happen, or what can happen is w plus reverse of u is from t and u is from s. Like either of these two cases can be possible, right? Or what can be possible is that the entire substring is from only one string. Like if the longest palindrome is from just one string, then that's also possible. So in that case, this u will be equal to the empty string. Like u will be equal to 0. Okay. So this is the only case that we are worried about. That either our string p will look like u plus w plus reverse of v, and either u plus w is from s, or w plus reverse of u is from t. Okay. So I hope this part is clear. This is just a formally I am telling you what I told above. So this should be clear, I hope. So now our problem boils down to, we have to search for two strings. Basically, we have to search for two strings u and reverse of u. Like let's try to search for these strings first, u and reverse of u. Okay. So basically what we want is that we have string from u, like we have a string u from s, okay, and we want its reverse of u from t, okay. So let's just try to find these strings first, and then what we want is we want a w, okay. And one more thing I forgot to tell you, one more thing is that this W, like this W or this W, both in both cases, this W will be a palindrome. This will be a palindrome in itself, right? Because we want the entire string to be a palindrome, right? So this U and reverse of U corresponds with each other, right? So therefore this W has to be a palindrome. As you can see from here, this AB and BA cancel out, but this middle string has to be a palindrome also, right? So that's what my point is, that our form will be of U plus reverse of U plus a palindrome, and that palindrome can either be from S or it can be from T, like from the first string or from the second string, right? But it's like it has to be that wherever U ends, W has to start from there. Okay, like we cannot have two disjoint substrings from the string S. Like we cannot do something like this is string S and this is U. We are taking U as this and W as this palindrome. Let's say this is a palindrome ABA. So we cannot do this because we want to choose one substring from the entire S, right? So if we want to choose W, it has to start from the next character where we left W, where we left U. Okay. And same for T. Like in T, what has to be there is that, let's say we are taking reverse of U here. This is reverse of U. Then our W has to end here. Like this W has to end before the starting of U, like just before the starting of U. So ABA, let's say this is W, then it has to end just before just before the starting position of U, or reverse of U. Sorry. All right. So this kind of motivates us to find out, like, let's say I want to find out that in string S, like in string S, I want to ensure that this W starts from this index, right? I. So basically, what we want that, okay, starting at I, what is the longest palindrome? Like in a string S, we have a string S, and for every index I, if I figure out that starting at I, what is the length of longest palindrome in S? Like if I figure that out, if I know that answer, then it is helpful, right? How it is helpful? Because let's say I have already chosen a substring S, sorry, a substring U, like this, and from T I have chosen a substring reverse of U, right? So by default, U plus reverse of U is a palindrome, right? So if we just take these two and these two, it is an answer. But what we can actually do is we can insert extra elements in between. Like if there is a palindrome which starts at I, like let's say this entire string is a palindrome, then we can insert this in between U and reverse of U, right? So if I have the maximum length of a palindrome which starts at an index I, then basically whenever I end at some index, I can add that length to my answer. Like in that case, the answer would be just length of U plus length of reverse of U, which is same as length of U, plus this extra portion, which is the length of palindrome starting at I. Right. Sambhuda is asking, but then we have to find the longest palindrome at every string for both S and T. Yes, exactly. We have to find the longest palindrome starting at I for S and T. Like for S, we have to find the longest palindrome starting at I for every I. And for T, like, and for T, what we have to do is we have to find the longest palindrome ending at j. Okay, for every index. Yes. So how do we do that? Like this is actually, we are allowed to do it in O of n square, right? Because n is up to 1000. So let's say our problem is now to find the longest substring. Sorry, the longest substring, yeah, starting at I. Like in problem is to find longest substring starting at index I in string s for every I, right? We have to find the longest substring starting at index I for a string s for every I. Okay, so to do this, actually we can do it in O of n square, right? We are allowed to do it in O of n square. So we can do that. And how, like what we can do is, we can, let's say, give a boolean dp. Like, okay, first I'll give an intuition, right? So let's say I want to check whether a substring, let's say this is string s and this is index I, this is index j. Let's say I want to check that whether this substring from I to j is a palindrome or not. Okay, that is this a palindrome or not? So what can I say? That this is a palindrome if and only if these two are same, that si should be equal to sj, and this I plus 1 to j minus 1, I plus 1 to j minus 1 is a palindrome. Okay, that's the thing. So for that, so basically this motivates us to create a dp, right? Like, since we are recursively defining our palindromeness, we can define a dp of I comma j. Like it is a boolean dp, like it's either true or false. So it is true if s of I to j, s from I to j is a palindrome. Okay, so if I keep this dp, so how will I transition? Like dp of ij, how will I calculate? This is so dp of ij I can easily calculate that, okay, if I equal to j, then of course it is true, because length is just one. It is just one character, right? So it is obviously a palindrome, right? So dp of ij equals to true. Okay, and also if I equal to j plus 1 or j equal to I plus 1, then it is true if and only if si equal to sj, or si equal to s of I plus 1, whatever. Like if j equal to I plus 1, that means there are two characters, like a b. So if they are equal, then only it is a palindrome. So s of I equal to s of I plus 1. And otherwise, like if j is even greater, that is the length is at least 2 or length is at least 3, then we can say that dp of I comma j is equal to dp of I plus 1 comma j minus 1 and s of I equal to s of j. Okay, so this is a transition that we can do, right? So is this clear to everyone? Until here, is it clear to everyone that how will we find out the longest palindrome ending at I or starting at I? Like once we have this dp, it is pretty easy to calculate that for every index I, what is the length of longest palindrome starting at I, right? clear but small recap. So what I want to do is I want to solve this problem. Find the longest substring starting at an index I in the string S. Like I want the length of longest substring in S which start as an index I. So starting at some index, I want to know that how far can I go such that this substring is a palindrome. So to do that, I have kept a boolean dp where dp of ij is true if s of I to j, matlab the substring from index I to index j, it is a palindrome. So how do I check if it is a palindrome? I can just check that the substring from I plus 1 to j minus 1 should be a palindrome and si should be equal to sj. So that is the transition here. dp of ij is equal to dp of I plus 1 j minus 1 and si equal to sj. Okay. Is this recursive dp you are talking about? Like, okay, the implementation is up to you. Like, if you want to implement dp recursively, then you can implement it recursively. And if you want to implement it iteratively, you can do that also. Okay. But I have implemented it iteratively. So what I have done is I have observed that the dpij depends on I plus 1 comma j minus 1, right? So okay, let's say I show it pictorially. Okay. So this is a grid. This is the dp grid, and this is I. Like I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4. And here this is j. So j equal to 0, j equal to 1, j equal to 2, j equal to 3, j equal to 4. So dp of ij, let's say this is dp of ij. It depends on what? It depends on I plus 1 comma j minus 1. So it depends on this, right? So every cell depends on its diagonally bottom left one, right? This way. So what we can do is we can calculate the dp in this fashion. Like we can just first calculate this one, then this one, then this one, then this one, then this one, and then this. So whatever dependencies are there, it will be satisfied. Like if we calculate, like what essentially what I am doing is for I equal to n minus 1 to 0 and for j equal to 0 to m minus 1, right? So when I am at I comma j, dp of I comma j, right, what I want is that dp of I plus 1 comma j minus 1 should have been visited, like it should have been calculated correctly. So since I am traveling from j equal to 0 to m minus 1 and I am at dp of I comma j, okay, wait, since I am at, since I am traveling from I to I from n minus 1 to 0, right? So since I am at I, that means that I have already been to I plus 1. Like if I am at 2 right now, that means I have come from 3. So that means that dp of I plus 1 has already been calculated for every index. Like dp of I plus 1 comma j, I have for every j I have the value. So I can do this. Okay, this is how you implement this iterative dp. That dp of ij equal to dp of I plus 1 j minus 1 and si equal to sj. Okay, and then you can just store the maximum length of the of a palindromic substring which starts at I, right? Okay, just a second. Yeah, sorry for the delay. So what I was saying is you can easily calculate your answer using this DP. So I'll show you the code for this part. Like, this is not over. Our problem is not over, but I'll show the code for only this part. Okay. Yeah. So this is the thing. Wait. So here my PS is my DP. Like the DP for my string S. Okay. So what I'm doing is I equal to n minus 1, I greater than equal to 0, I minus minus, j equal to I. Okay, actually I start from j equal to I because the substring is from I to j. So j less than I doesn't make sense. So I start from j equal to I, j less than I, and j plus plus. And PS of ij, that is the DP of ij, is equal to either j minus I equal to 0, right? If this is true, then the length is just 1, or j equal to I plus 1 and si equal to sj. So either this is 1 length or this is 2 length, or if it is greater than 2 length, then we can define it recursively, like, or ps of I plus 1 comma j minus 1, that is dp of I plus j minus 1, and si equal to sj, si equal to sj. uh yeah. Okay, so this is my transition, and if my ps of ij is true, that means that starting at index I, that is max s of I have kept a vector of max s, maximum length of palindrome in S starting at I. So that will be max of max s comma j minus I plus 1. So this palindrome I to j is of length j minus I plus 1, right? And it starts at I. So I just take the maximum. And also, this is also a possible answer, right? My final answer can be this also. Like, my final answer can be either of this form, that I have something from S and something from T, or it can be of, like, it can be that entire string is only from one string. Like, we are allowed to choose an empty substring also, right? It is possibly empty. So it is possible that I am choosing the entire substring from either S or from T. So this S of I to J, it is a palindrome. So it is also a possible answer. So I am just taking the max of the answer also. Ans equals to max of ans comma j minus I plus 1. Aren't you going out of bounds? PS of I plus 1 when I equal to n minus 1. No, when I equal to n minus 1, then uh, here it will be satisfied. Like, okay, when I equal to n minus 1, then j will also be n minus 1. Like, j cannot be greater than n minus 1. So here only it will satisfy. It will be true here. So it won't go ahead. Like, it won't go forward. If you know that, like, if you have an or statement, this is pretty, yeah. If you have an, if you have a or statement, then if this comes out to be true, then C++ compiler will not evaluate the ahead statements. This is called short circuiting. Okay. Anyways, so this is the DP by which we can calculate what is the maximum palindromic substring length starting at index I or ending at index I. Right. So for the string T, what I have done is I have calculated the ending at index I. Like, this is pretty weird. Yeah. So for max T, I have maximum length of palindrome in T ending at I. Okay. So I have done the same thing for that. Just max T of J I have done. Here I have done maxes of I, but here I have done maxes of J, max T of J. Okay. But everything else is same. Right. So now that we have solved this sub problem, that find the longest palindrome starting at index I or ending at index I. Okay. So now that we know this, what we are left to do is what? Just find these two parts. Like, basically, what I have solved right till now, what I have solved till now is that if I have these two parts, then I can find the maximum length of this part, right? Till now I have reached till here, but how do we find these two parts? That is the question. Okay, so what we are left with is that we have a string s, right? We have a string s and we have a string t, and we have to find two substrings from s and t of equal length, right? They have to be of equal length, such that if this is u, then this should be reverse of u. Okay, we have to find this out, and we have to maximize the length of u plus this thing. So basically we can just check for all u. So let's say we are trying for this u. Okay, if we are trying for this u, then our answer would be what? It will be 4 plus 4 plus whatever is the maximum length of substring or palindrome which starts at here, either this, like plus max of, let's say this is the value written here is something k1, like our the length of maximum palindrome starting here is k1, right? And the length of maximum palindrome ending at this character is k2. So our answer would be max of 4 plus 4, which is this 4 plus this 4 plus max of k1 comma k2, right? So if k1 is bigger, then we'll take a substring from here which is a palindrome, and if k2 is bigger, then we'll take a substring from here which is a palindrome, right? So now what is left is to find out this u and reverse of u. Okay, so to find that out, what we can do is again dp. Like, okay, i have let's say I have this thing, that this is index I, let's say this is index I, and let's say this is index j. Okay, so since, now notice that I is the ending letter of u and j is the starting letter of reverse of u. Okay, and not the letter, it is the index, my bad. So I is the index, j is the index. So since u and reverse of u, so that means that s of I equal to t of j, right? These two letters are same, then these two are same, then these two are same, and also these two are same. This is a bit messy, but okay, you get the point, right? So let's say from I comma j, okay, from I comma j, we want to find out that till where can we go. Like from I comma j, we want to find out that till where can we go, so that it is like u and reverse of u, right? So if I take example, let's say we have 1 2 2 3 or okay, the letters, right? So a b b c d, and here we have c b b and c. This is string t, this is string s. Okay, and let's say I want to calculate that for this index and this index, how much left can I go in this one, and how much right can I go in this one. So the answer to that is that I can go till cbb, and here I can go till this cbb, right? Or actually instead of doing that, what we should do is we should check for this index actually. See, um okay, my bad, this was a mistake on my part. So let's say we want to find out that um uh okay, it is correct, sorry. So see, what I am saying is that for a certain I comma j, for a certain I comma j, what is my answer? Like I'll summarize again. Okay. For a certain I comma j, let's say I have chosen that this is I, or this is I, and this is j. And what does this mean? This I means that my u is ending at I. This is my u which ends at I, and j means this is my reverse of u which starts at j in t, right? And so what is the answer for ij? Like for this particular ij, what would be the answer? What the answer is, that the longest length of palindrome, right? So for this particular ij, it would be basically how much left can we go from I, and how much right can we go from j, such that this u, that s of that thing, like this u substring should be reverse of this, like, or this should be reverse of that, whatever, the same thing. So how much long can we go? So let's say we can go till x characters. Like here x is 4 in this diagram, so let's say we can go to x characters. So the answer would be 2x plus whatever is the longest palindrome, like starting at this index. I have named it what? I have named it max s, right? So it is 2x plus max s of I, or max t of, sorry, not I plus 1, sorry, right? Because since this u ends at I want the palindrome to start at I plus 1. So max s of I plus 1, comma max t of j minus 1, like this index j. So I have to check for this index j minus 1. Okay, all right. So whichever is the bigger, like whichever is the bigger one, we'll take the maximum of that. All right. So that's our answer. So basically, to maximize this value, we have to maximize this term and this term also. So we have to basically find out that if we end at index I in S and we start at index J in T, then how much left can we go in S and how much right can we go in T? And that is also a recursive thing. Like to find that out, what we have to find out? We have to find out that for a certain I comma j, that this is string T, this is string S. For a certain I comma j, how much left can we go and how much right can we go, right? So to calculate that, we can basically ask that, okay, first of all, s of I should be equal to t of j, right? If we want to consider them as our answer, then s of I should be equal to t of j. Okay. And if that is the case, then we can basically check for the answer of I minus 1, comma j plus 1. Like if I have the answer to I minus 1, comma j plus 1, like see, I am finding out the answer for I comma j, right? That starting from I and going left, starting from j and going right, how much can I go, right? So to find that out, I can, if I have the answer that starting from I minus 1, how much can I go? Like let's say I can go till here from I minus 1, and from j plus 1 I can go till here, right? Three letters. Then if I and j are same, like if si equal to tj, then I can just add this also. So I can start from here, right? So yes, exactly. It just depends on I minus 1 and j plus 1. So my dp of ij is equal to 0 if Si is not equal to Tj, and my dp of ij is equal to dp of I minus 1 comma j plus 1 plus 2 otherwise. Like, why am I doing plus 2? I am just defining my dp as the total number of characters. Like, in this case, if I can go till 4 and 4, then I am defining that my answer is 8, because total 8 characters we have. Okay, so here I won't do 2x, I'll just do x, or I'll just do dp of ij, right? So you can just store this dp, and for all ij I can simply calculate this dp, and for all ij I can calculate the optimal answer, which is this dp of ij plus the max of s of I, max s of I plus 1 comma max t of j minus 1, right? And that's my final answer, that for all ij I'll just take the maximum for all. So like, do you want me to dry run on a test case? Like, on this test case maybe I can dry run if you all want, or if you did not get a specific part of it, then also I can explain. So do you get it, or do I need to explain further? Okay, got it. So I will, so yeah, I'll summarize the whole thing, that okay, let's say at this is s and this is t, and you have an index I and you have an index j, right? So you want to calculate that if I end at index I, if my u ends at index I and my reverse of u starts at index j, then how far can I go? How much is the maximum length of u? And also I have to calculate that what is the maximum length of palindrome starting at I plus 1 and maximum length of palindrome ending at j minus 1. And I can just combine all of the answers to get the answer for a certain I comma j, and I can then calculate the answer for all I comma j and take the maximum, right? Okay, so then I'll show you the code. So till here I've already showed you, right? These two for loops are just for calculating this max s and max t, that is the maximum length of palindrome in string s starting at I and maximum length of palindrome in string t ending at I, right? Now I'll just show you the dp part. This dp part is like, I have vector of in dp, which is of n by m. So this stores that how far can I go, and twice that amount, right? So for int I equal to 0, I less than I plus plus. For int j equal to m minus 1, j greater than equal to 0, j minus minus. So here I am doing somewhat opposite of what I did above, like the dpi iteration order. Here I was I equal to m minus 1, I greater than equal to 0, I minus minus. Like, I was starting, I was doing reverse in I and forwards in j, but here I am doing reverse in j but forwards in I. And why am I doing that? Because this dp of ij depends on dp of I minus 1 comma j plus 1. So since dp of I depends on dp of I minus 1, I will iterate in the forward direction. So when I am at I will already have crossed I minus 1. Okay. So now if we are at ij, so if s of I equal to t of j, okay, if s of I equal to t of j And also it is not the first and last character. Like I is not the first index and j is not the last index. Then I will do dp of ij equals to max of dp of ij comma dp of I minus 1 j plus 1 plus 2. Actually I don't even need this max thing. dp of ij will be just dp of I minus 1 j plus 1 plus 2. And if it is an ending index, then obviously the dp is 2, like because we cannot go any further. And by default the answer to this dp is 0. Like by default the answer is 0. So let's say we could not go further, then this dp of I minus 1 j plus 1 would be 0. So it works out fine. And if it is an ending index, like if I is equal to 0 or j is m minus 1, then obviously my dp ij is 2. Okay. And now I have like the middle string, right, which is in itself a palindrome, which either starts at I plus 1 or it ends at j minus 1. So I am just calculating the maximum length. So either it's so okay, if I plus 1 is less than n, like if it is not the last character, then I can take um extra equals max of extra comma maxes of I plus 1. And if j minus 1 is greater than or equal to 0, that is j is not the first character. In that case, extra equals to max of extra comma max t of j minus 1. That means I am considering both, that substring starting at I plus 1, which is a palindrome, and substring starting at j minus 1, which is a palindrome. And my final answer is max. So my final answer for I comma j, this I comma j, is extra plus dp of I comma j. Extra is the middle part. All right. So I hope this is clear, and in the end I return the answer. So I hope this is clear. Okay. So if it is not clear to anyone, then please ask your specific doubt. And in case you did not understand the most of it, then I recommend you to like rewind the video and play it again, maybe slowly or in normal speed, like whatever you want. Thank you, Prince. Okay, so if this is done, then I'll move on to the next one. Okay, so the last problem for today is you are given an integer array nums and two integers x and y, x and k. You can perform the following operation any number of times. Increase or decrease any element of nums by 1. Return the minimum number of operations needed to have at least k non-overlapping subarrays of size exactly x in nums, where all elements within each subarray are equal. Okay, so basically the problem says that we have an array A, right? We have an array A. Okay, and let's say it has some numbers. Okay, 2 3 1 2 5 6 7, and we have to change these numbers. Like we can operate on these numbers, and like we can select any one number. Let's say select this number, and I can either decrease it or I can increase it by 1. Okay, and I have to make sure that there are at least k non-overlapping subarrays of size exactly x, where all the elements within this subarray are equal. So okay, let's say k is equal to 3 and x is equal to 2. So that means that I need um, 3 subarrays of 2 size, okay, such that in each subarray all the elements are equal. Okay, so for example, this array can be turned into what? Let's say I subtract 3, like I subtract 1 from this, so it becomes 2 comma 2. Then I subtract 1 from this 2 as well, so it becomes 1 comma 1, and then let's say I subtract 1 from this 6 also, so it becomes 5 comma 5, and then comma 7 we have. So these three subarrays, which are of length 2, they have like all equal elements, and actually I had to do the operation 3 times, right? One for this, one for this, and one for this. So the answer is 3. Now note that we can, like, in one operation we can only decrement it by 1, increase or decrease any element by 1. So if we want to decrease it by more than 1, then we would have to apply the operation multiple times. Okay. All right. So all right. So now what to do? Let's think about this. So first of all, let me ask you one question. Okay. Let's say I give you a subarray. Okay. Let's say um, I give you this only 2 3 1 2 5 6 7 2 3 1 2 5 6 7, and I want to ask you that, let's say I want that this whole subarray becomes equal to x, like some value x. Then how many operations will that take? Okay, that is my question. That how many minimum operations will it take? Now it is pretty simple, I think. Like basically you want to convert this 2 into x, right? And you can increment or decrement the number by 1 in each step. Prince is saying difference of max element minus min element. I think you don't get the problem. Like, don't get the question. Like, let's say I want to convert all of these elements into 3. Okay. I want to convert all of these elements into 3. No, no. What I am asking is that let's say I give you the x. Like, for a certain x, what is the answer? That I want to convert all of them into 3, then what is my number of operations? So, that is just 2 minus 3 absolute value plus absolute value of 5 minus 3 plus absolute value of 6 minus 3, right? So for x in general, if I say that my elements are 2 5 and 6 and I want to convert them into x, then number of operations that I want, like that I have to do is x minus 3 mod plus mod of uh, x minus 5 plus mod of x minus 6, right? 1 plus 2 plus 3, yes, exactly. So um, if I want to, like, change a subarray ai to aj, like ai plus 1 up to aj, I want to change this subarray to a value of x. Then the minimum operations that I have to do is a of I minus x plus a of j minus x plus a of k minus x, and sorry, a of what am I writing? Sorry, uh, just a minute. Huh. Um, what I was saying? Yeah. So a of I minus x, a of I plus 1 minus x, a of I plus 2 minus x up to a of j minus x. So this is your cost, minimum cost, if you want to convert this entire subarray into x. But now, how do I choose this x which minimizes this cost? Like, I can convert this entire subarray into anything, right? They have given me that liberty that I can convert it into any number that I want. So how do I choose that number such that this cost is minimized? Does anyone know already? Like this is a very well known fact actually. So do any of you already know this? That how do we choose this x which minimizes this cost? Take the median. Yes, exactly. Basically, whatever is the median of these numbers, ai, a plus 1, aj, that is the um, optimal choice to take. Like this is a very well known fact. Actually, if you want to Google like minimize absolute mean absolute deviation. So this is like a page where you can actually read about the proof of this also. That suppose we have a set of real numbers, so that mod of s minus x का sum is minimal if x is equal to the median. So this is one fact that we can use here, and the proof is like, I think actually it is quite simple, but actually do you ex- sorry. Yeah, so the proof is actually quite simple. Um, so should I explain it or not? Let me just try to give you a hint about it. Okay. All right. So let's plot this numbers on a number line. Okay. So let's say I have these numbers ai plus 1 up to aj. Okay. Now let's assume that they are in ascending order. Or okay, let's say that I sorted these and my new array is now bi plus, or my new array, I sorted these elements and my new array is now b1, b2, b3 up to b of j minus I plus 1. Okay. Prince, we can change in one operation only one element. Yeah, so I have sorted the array and it has now become this. So b1 is less than b2 less than b3 or less than equal to. Okay. So let's plot them on a number line. All right. So we have b1 here, b2 here, b3 here, and so on up to b of n. Let's say b of n we have, and let's say our x is somewhere b of n minus 1. Yeah, so let's say our x is somewhere. Okay, our x is here. Okay, so x is between some two elements, right? Like let's say this is bi and this is b of I plus 1, and let's say x is between b of I and b of I plus 1. Okay, so what would be our error in this case? Our, I mean, not error, our cost in this case. Our cost would be just x minus b1 plus mod of x minus b2 plus up to absolute value of x minus bn. But actually I can open these absolute values, right? Because I know the relative order of these numbers. So x minus b1 ka mod is just x minus b1, uh, because basically b1 is less than x, right? So plus x minus b2 plus up to x minus bi. Okay, but now b of I plus 1 is greater than x, so it becomes b of I plus 1 minus x plus b of I plus 2 minus x, and so on up to b of n minus x, right? And now let's assume that x is a median. Like for now I am assuming that x is a median, and then I will prove that if I change this x to somewhere else, then it will definitely make the answer worse. Okay, like what my proof is, basically I am assuming that x is a median, and I'll then prove that if I just change x to anywhere else, then it will make my answer worse. So that is a, good proof, that like that is a sufficient proof, right? So I am assuming that x is a median. So since x is a median, what does that mean? It means that the number of elements to the left of x is equal to number of elements to the right of x, right? That is the definition of median. Okay. So the number of elements left of it equal to the right of it, right? So what I can say is that these positive terms and these negative terms are currently equal. Like their number is equal. Okay. So these, like here it is plus x, right? So plus x plus x plus x sometimes, and here it is minus x minus x minus x equal number of times. So all these x's get cancelled out, and we are left with what? Minus b1, minus b2, minus b3 up to minus bi plus bn, or okay, bi plus 1 plus bi plus 2 up to bn. So this is what we are getting if we take x as a median. Okay. But now let's say I don't take x as a median. Okay. Let's assume that I take x as here, like after b of I plus 1. Right? If I take x after b of I plus 1, then what will change? Then basically what will change is that initially this b of I plus 1 minus x was there, right? So this will become x minus b of I plus 1, because now x is greater than b of I plus 1. So whatever was initially, like it was b of I plus 1 minus x, now it is b x minus b of I plus 1, right? So now our sum is what? Basically now um, we have two x's extra, right? Or let's just calculate the difference between these two. Like okay, in initial case what we had, that x minus b1 plus x minus b2 up to x minus b of I plus b of I plus b of I minus x up to whatever b of n minus x. But now that we have changed x, like now that we have changed this x to a y, let's say, where y is between b of I, the b of I plus 1 to b of I plus 2. So in this case, my penalty or my cost would be y minus b1 plus y minus b2 up to y minus bi uh, plus y minus b of I plus 1 plus b of I plus 2 minus y up to b of n minus x. So basically, sorry, I plus 1 आएगा यहाँ पे. Yeah, so x minus b1 x minus b2 up to x minus bi plus b I plus 1 minus x up to bn minus x. Okay. So this will become what? Minus b1 minus b2 up to minus bi plus bi plus 1 plus bi plus 2 up to bn, right? And what is the second expression? The second one is what? Okay, first of all, one thing to notice is that these number of terms and these number of terms were equal initially, but now this term has come into this group, right? Like now it is something like this. This is one group and this is one group. So the number of positive y's, the number of positive y's is 2 more than the number of negative y's. Okay. So 2y will be remaining. Like 2y's will be left. So it becomes 2y minus b1 minus b2 up to minus b of I minus b of I plus 1, and we have plus b of I plus 2 plus b of I plus 3 up to b of n, right? So my I am basically saying that this is the initial cost, this is the final cost, and we want to prove that the final cost is greater than the initial cost, right? So how to compare these two values? Basically, this minus b1 minus b1 is same, so we can cancel it out. Minus b2 is same, and up to minus bi it is same, right? And again for b of I plus 2, b of I plus 2, it is same, b of n, b of n. So all the positive terms are same. Just what is not same? So what is left now? Above it is left b of I plus 1, right? And below it is 2y minus b of I plus 1. So we want to check that which one is greater, or we want to prove that this one is greater, this 2y minus b of I plus 1. So we can easily prove that, because b of I plus 1, let's assume this. So b of I plus 1. So this implies, and implied by b of I plus 1, 2b of I plus 1 is less than 2y. So b of I plus 1 is less than y. And this is true, right? We chose y which was greater than b of I plus 1. So that's why this entire thing, this entire thing is always greater than this entire thing. And that's why taking the median is always better. All right. So this is the proof for what I was saying, that to minimize this cost, a of I minus x, a of j, a of I plus minus x, a of j minus x, it is always optimal to take the median. Okay, so did you all understand the proof? Okay, so I am assuming that you all got the proof. So now that we know that we have to take median, right? So if we want to fix a subarray, then we have to take a median, and we can just calculate the value of the median and calculate the cost to fix a subarray, right? And what I mean by fix is to make all the elements equal. Okay, that is what I'm calling as fix, right? So now let's assume that magically you have a function that returns you that number of, like, it returns you that what is the cost to fix a of l up to a of l plus x minus 1. Like, since we want like exactly x length, right? We just want um exactly x length to be equal. So let's say you have a function which tells you that what is the cost, what is the minimum cost to fix a of l up to a of l plus x minus 1. Like, this returns in o of 1. This returns the answer in o of 1 time, let's say. Let's assume you have a function. Then how can you use this function in order to determine the answer? Like, essentially what you have to do is that you have to make k subarrays, make k subarrays such that um, like the element in them is equal and their length is x. And yeah, the constraints on k are also pretty small. Like, k is only from 1 to 15. So actually we can also do n into k dp, right? So what we can do is that we can keep a dp. Okay, we can keep a dp of n into k or n into k plus 1. This is the size of the dp, where n is the index. Like, where n is the index of the prefix. Like, if we consider only the prefix I, basically what does dpij denote? Dp of ij denotes that considering only the prefix I, what is the minimum cost to form j fixed subarrays. Okay, so this is my dp, that considering only the prefix I, that is array of 0 to I, what is the minimum cost to form j fixed subarrays. Okay, so how do we calculate this dp? It is like pretty easy, right? That, let's say my x is 2 or x is, let's say, 3, and I want to calculate the answer for this. Okay, I have the answer for all of these indices, and I want to calculate the answer for this index. Okay, so either it is like, so my dp of I comma j. Okay, so this is the index I, right? So either I can have j sub arrays from this only. Like, let's say I don't even take this I into a sub array, then that means that I have j sub arrays from this one only. So in that case, my cost would be the same as my I minus 1 comma j, dp of I minus 1 comma j. Or what we can do, like, or either we don't take this element, or what we can do is we can take this element. So in that case, this subarray would have to be fixed, right? This is one subarray that would have to be fixed. So basically, in this prefix, we need j minus 1 subarrays. So either we can not take this element in a subarray. So in that case, the answer is dp of j I minus 1 comma j. And otherwise, if we take this element, that means that we are doing the operation on this subarray. So that means my answer would be dp of this comma j minus 1. So if this is I, this is index I, then this is the index I minus x, right? So my answer would be dp of I minus 1 comma j, or dp of I minus x. So I minus x tak I want j minus 1 subarrays, because one subarray I have here. So I minus 1 tak I want j minus 1 subarrays plus the cost of I plus, or I minus x plus 1 to I. Like, whatever is the cost of fixing this subarray, that we will add into this. So dp of I minus 1 j, that we do not take this element, or if we take this element, then we have to fix this subarray, and we want j minus 1 subarrays from the I minus x, right? So this is my transition, like, uh, minimum basically. uh, this one and this one, their minimum is my dp of I comma j, and my final answer would be dp of n minus 1 comma k. Like, the last element, comma, I want k sub arrays. All right, so this is my thing, like, this is my entire method. But now what is remaining, that how do I calculate this magical function? like this function which returns me the cost of my conversion in O of 1. How do I calculate that? Like, how do I do that? So essentially, what is the cost? Let's recall that. So I just told you that let's say you want to fix the array ai ai plus 1 up to a of j. You want to fix this subarray. Then the cost is that, okay, let's say that the median is something x, right? Then the cost is mod of ai minus x plus mod of a of I plus 1 minus x up to mod of aj minus x, right? Where x is the median of ai to aj. And you want to calculate this for all subarrays of length x. Actually, this is not x. Let's take this y because x is taken. So yeah, so you will calculate this value for all subarrays of length x, where x is the input. X is given in the input. So the length that we have. So we want to calculate this value for all subarrays of length x, right? So what we can kind of do is a sliding window technique. Like let's say this is x. Let's say x is 3. Okay. So first three elements we have. And so this is a window and we can slide it, right? Like this. And we can compute the answer for each. But how do we like compute the answer? That is the question. That how do we efficiently update the answer from this subarray to the next subarray? Right? That is my question. So what is my answer? My answer is just this, that if y is the median, then I want to calculate a mod of ai minus y, mod of ai plus 1 minus y up to mod of aj minus y. So actually I can break this into two parts, right? Into two parts I can break. One where ai is less than y. So all of the terms where ai is less than y, they will open like y minus ai plus y minus a of I plus 1 up to y minus whatever, like a of j, let's say, or not a of j. Let's just say I sorted this array. Okay, like this ai to aj I sorted. Okay, I sorted this ai to aj and it became b1, b2, b3 up to b of j minus I plus 1. So let's just say I break this into two parts. Okay, so we have y minus b1 plus y minus b2 plus y minus b3 up to y minus bi, let's say. So this is one part of the sum. Okay, plus I have b of I plus 1 minus y plus b of I plus 2 minus y plus up to b of n minus y. So this is the one part and this is the other part. Okay, and you want to calculate this. So okay, y is the median, right? Y is the median. So essentially you want to calculate the sliding window median also, and then using that median you also want to calculate this sum, right? So guys, do you know how to calculate the sliding window median? Do you know how to calculate that? There are like multiple methods. Prince says no. Okay, doesn't even know how to calculate that sliding window median. Like you want the median of all these subarrays of length x, right? So doesn't even know. Okay, I'm assuming that no one knows this, so I will explain. Okay, I'll explain that how do you calculate the sliding window median. Okay, so to do that, actually you can maintain two multisets. Okay, just maintain two multisets, right? Which contain all the elements which are in this range. Like let's say there are two multisets, one is called low and one is called high. Okay, and you want to like maintain all the elements such that just 1 minute. Yeah, my bad. So let's say you have two multisets where one is called low and one is called high, and every element in this range is in either low or high. And what I am doing is I am basically keeping the lower half of the elements. Like let's say the elements are 2, 7 and 5. So I will keep the lower half, like 2 and 5, I will keep in low. Okay, and the upper half I'll keep in high. I'll maintain like this. Okay, that the lower half of the numbers, like 2 and 5, I will keep in low, and the upper half I will keep in high. So essentially, if you notice that if I keep it like this, if I keep my two multisets like this, that my ceiling of x by 2 elements should be in low, and my GIF of x by 2 elements should be in high. Like the first half should be in low and second half should be in high. Then if you see that what is the median, in that case the median is just the highest element in my low array, right? In my low multiset, my median would be just the highest element in my low multiset. Okay, is that cool? I hope it is cool. So let's assume that, like, okay, let's say you know how to maintain these two multisets. Like let's say you are here and then you go ahead with the next window. In that case you would have to remove this two and insert this element, whatever is here. So um, I will tell you how to do that. It's actually somewhat complicated. Like it is not that easy to maintain these two. Like because you want to maintain two things, right? You want to ensure that all of these elements are less than these elements. Like this is the lower half, right? And also you want to ensure that these contain half and these contain half, or these contain x by 2 elements ceiling and these contain x by 2 elements floor. Okay, so yeah, my point is that I'll tell you how to maintain that, but first let's think about how do we actually calculate our answer also. Like I just told you that our median is the highest element in this low, right? This is my y, the highest element in my low multiset. But how do I calculate my answer, where my answer is this, right? Mod of ai minus y, mod of a minus y, and so on. Why can't we use heap instead of multiset? Because we want to erase elements also. Like C++ heap, which is priority queue, it does not allow us to erase elements. So that's why I'm using multiset. But yeah, theoretically we can use heap if we can erase elements from that. But actually, erasing elements from heap, I think, is not supported. Like, it is not possible to erase an element using its key. That is not possible. So we have to use a heap. Sorry, we have to use a multiset. Okay. So we are using a multiset, and what we have to do is that, okay, the our median is 5. Our median is the highest element in our set. But what is our answer? Basically, what we want, that the median is y. So our answer is what? Mod of 2 minus y plus mod of 5 minus y plus mod of 7 minus y. Right? But one thing that you can notice is that all the elements in low, suppose u I take, all the elements u in low are always less than or equal to y, right? Because y is the highest element of low, right? And all the elements of high, suppose h, all the elements of high, that is h, suppose they are always greater than equal to y, greater than equal to median, right? So using this invariant, we can actually write this penalty as what? Basically, let's say our low contains the elements u1, u2, u3 up to un. Like, our low has the elements u1, u2, u3 up to um, or u of ceiling x by 2, and our high contains the elements l1, l2 up to l of gi of x by 2, right? So our median is this, right? Median is u of x by 2. So I'll call it y. So my penalty is what? My penalty would be directly y minus u1 plus y minus u2 plus up to y minus u of c x by 2, right? Plus l1 minus y plus l2 minus y plus up to l of x by 2 gif minus y. So this is our entire turnaround. Like, this is our conclusion, that this is my final penalty for these two sets, low and high. So is this clear, guys? How I got this penalty? Is it clear, everyone? Okay. So given this, I can actually write this like what? There are uh, x by 2 terms here, right? So ceiling of x by 2 into y minus u1 plus u2 plus u3 up to ux by 2. So it is the low, sum of the elements in low, plus gif of x by 2, sorry, not plus, so plus it is L1 plus L2 plus L3 up to L of x by 2. So plus sum of high minus J of x by 2 into y. Okay. So this is my final penalty. So what I'll do is I can just maintain the sum of my elements in my sets or my multiset. That what is the sum of elements in my multiset low and sum of elements in my multiset high, and I can easily calculate this penalty. But now the final question is that how do we maintain this low and high? Like, how do we erase elements from this, and how do we insert elements into this? Okay. So essentially, like, that's what you need to do, right? So initially you will have these x elements. Then you will move the sliding window. You will move this window So what you will have to do is you will have to erase 2 and you will have to insert this element, right? So how do we do that? So that is also pretty simple actually. Let's say you have an initial 2, 3, and 7. Okay, and this is low, and high you have 9 and 20, let's say. Okay, and let's say you want to insert 5 into this, and you want to erase 9 from this. Okay, you want to insert 5 into this and you insert 9 into this, 9 from this. So there are multiple ways, but what I did was that I'll just insert 5 where it belongs. Okay, I will insert 5 where it belongs. What does that mean? That um like if the like if 5 is in the first half, like if the highest element in this low set, if that is greater than or equal to 5, then I will insert 5 in the low set, right? And let's say there was something, let's say there was 4 here, there are 4 here, then I will insert 5 into the upper half here, or rather here, right? So I'll insert just 5 wherever it belongs. So I will insert 5 here, right? And also I want to erase 9, right? So then I'll just erase 9. Like wherever 9 is, I will just erase it, right? So now that invariant is satisfied, that I need the lower elements here and the higher elements here. But my other invariant, that this should have half elements, this should have half elements, that is not satisfied. So what I'll do is I'll just transfer the highest elements from this set into this set, as long as the size of these two sets is not what I want. So as long as the size is not what I want, I will transfer these elements from this set to this set. And like when I'm inserting, or when I'm erasing, or when I'm transferring, I will keep track of the sum. Like I'll keep updating the sum, the current sum, whatever in this set is. So I'll update that, and that's how I can get the penalty for each multiset, and that's how I will get the penalty for each um, contiguous subarray of length x, and that's how I'll get this magic function, and that's how I'll get the cost, and that's how I'll get the DP, and that's how I'll get my answer, right? So, te- uh, yeah, we kind of did a DFS here. Like first we saw how to get the DP, assuming we know how to calculate the cost. Then we assume how to calculate the cost. Like we know, like we discussed how to calculate the cost, and to do that we discussed how to calculate the median, and then to do that we discussed how to calculate the, like how to maintain this multisets. So that's the solution here. So is it clear to all? Is it clear, everyone? Anish is saying looks like the approach is using some standard question. Yes, it is. This question is called sliding window median. Like there is this question on CSES. It's called sliding window median. Uh, yeah, this one. So this is the problem, and this uses, like there are many approaches to this, but I used this two multisets thing, right? Okay, yeah, code I will tell you. So yeah, here is the code, or I'll just open this in here. Okay, yeah, so this is the code. What I have done is I have a prefix sum. Okay, actually this is not needed. Like when I was solving it, I thought I would need it, so I made it, but we don't need it. Okay, so we have this dp of n comma k plus 1 size, and initially it has infinity into it because we want the minimum cost, right? And vector of long medium. So this is my magic function basically. Like this is my this vector stores all the cost. Like it is not the median, it stores all the costs for all the subarrays from I equal to 0 to I equal to n minus x plus 1. Okay, or n minus x, sorry. So I have these two multisets. Like I'm basically calculating this vector right now. Okay, like this bracket, from this bracket to like where this bracket, this entire code is to calculate this median. Okay, so I'll show you what I did if this UI works correctly. Yeah, so what I did was I kept two sets, multi-sets, low and high, and sum 1 and sum 2. So first I inserted the first x elements. Okay, so these first like three elements I inserted. So currently my window is this. So I inserted them into low. Okay, but actually I wanted that the highest elements are in high, right? So while low dot size is greater than x plus 1 by 2, I transfer them into high. Okay, so these four lines are just to transfer the highest element into high. So I just do sum 1 minus equals the highest element, sum 2 plus equals the highest element, high dot insert the highest element, and low dot erase the highest element. Okay, and then I just do median, or this is my magic answer, my magic vector dot pushback. Uh, Actually, I messed up this sign here, so I just added a negative sign later. So um, this is what I did. That okay, low dot size into low dot r begin, so which is the maximum element, minus the sum 1 plus low dot r begin into okay, like sum 2 minus low dot r begin into high dot size. So basically this expression right here which I wrote, um, x by, which was x by 2 into y minus sum of low plus sum of high minus x by 2 into y, where this is ceiling and this is floor. Okay, all right, so this is my formula, like you can verify. I won't go deep into that. So yeah, now what I'm doing is I am sliding the window. Okay, so I inserted the elements from 0 to x minus 1, right, initially. Now I will insert x. So I equal to x, I less than and I plus plus. So here I am inserting the element I, and I'm erasing the element I minus x. Okay, from my multisets, right? So if low dot size and star low dot r begin is greater than or equal to nums of I minus x. So what I'm doing is I'm erasing nums of I minus x. So if my median is greater than or equal to nums of I minus x, then that means my this element is in the lower set. It is in low. So I'll do low dot erase, low dot find nums of I minus x, and also sum 1 minus equals nums of I minus x, right? Otherwise I'll erase this from the high. So high dot erase, right, and sum 2 minus equals this. Now I'll insert, like I'll insert nums of I. Okay, so if nums of I is less than or equal to median, then I'll insert this into low, otherwise I'll insert this into high. Okay, so I have done the insertion and the removal, but now I have to just rebalance. Like I have to ensure that the size is apt. So if the size of low is too less, then I'll transfer the elements from high to low. Like I'll transfer the smallest element in high into low. So high dot begin, which is the smallest element in I. I will insert it into low. Okay. And otherwise, if low is too big, okay, then I'll transfer the highest elements from low into high. And after all of this is done, After doing all of this, I can again, like for the current I can push back the answer. I'll push back the answer, which is the same formula that I told you, right? So this is my magic function. Like this vector is basically my magic function, this median. All right, and then I just do the dp. Like here's the dp of 0 0 is 0, or basically dp of I comma 0 is 0. Like dp of ij is what? That we want j subarrays up to the ith prefix. So if we want 0 subarrays of same, then obviously the cost is 0. Like we don't want anything special, so the cost is 0, right? Then I will iterate from I equal to x minus 1, I less than an I plus plus. I am doing it from x minus 1 because before that, like for I up to x minus 2, we cannot do anything because we want the subarray length to be at least x, right? So that's why I'm starting from x minus 1. And for int j equal to 1, j less than equal to k, j plus plus. So we want j subarrays. Now if I equals to x minus 1, if I equal to x minus 1, that means that the first x elements we want to consider. So if I equal to x minus 1, then if j equal to 1, then dp of ij is median of 0. Like to convert, like to fix the first x elements, that is the answer, median of 0, right? And if j is 2 or more, then obviously we cannot do anything. So in that case, my dp would store 1e18, a very high value. Okay. And if x is not equal to I minus x minus 1, or if I is not equal to x minus 1, then I just do normal transition, that dp of I comma j is equal to minimum of either dp I minus 1 j, that is I don't do anything on this I, or dp of I minus x comma j minus 1 plus the cost of I minus x minus 1. So the cost of fixing the last x elements, like the elements from I minus x plus 1 up to I, that is the median of I minus x plus 1. And I'll add that into dp of I minus x comma j plus 1. And then I last may return dp of n minus 1 comma k. This is by mistake I have added. So just ignore this. I'll return dp of n minus 1 comma k. Okay. So I hope this is clear. So if it is clear to all, then I will end this PCD. I hope you all enjoyed. And if you have a doubt in anything, then you can ask in the comments also. I'll respond to that. Okay. Thank you all. Thanks, Anish. Thanks for responding also to my messages. Like it seems nice if the audience is responsive, and I'm not the only one who is speaking. All right. So, all right. Thanks. Thank you all for joining in, and bye bye.